Alrighty, hello, lovely Year 12s. Today I'm going to be introducing you to a new topic, systems of linear equations. Essentially what we're doing is we're just solving simultaneous equations. Typically in the past when you've done this, you've had two equations with two unknowns that you're solving. Now we're doing three equations with three unknowns. And so we've got this example here, we've got the three equations and both have the variables x, y, and z. And so we're just going to take a series of steps to eliminate one variable, then a second variable, and then come up with find a unique solution for that there. How does this link to vectors? Well, if you look at each equation and you think back to what you've done in the previous chapter, in chapter 5, we looked at the vector equation of a plane in 3D. And when you converted that to Cartesian form, you basically had an equation like these ones here. And so we can visualize, if you do have three equations, you'll have three planes, and we want to find the point of intersection like in this diagram shown below here. I've actually gone ahead and actually done a 3D graph of those equations here to show you. So I'm just going to share a different screen here. I'm just going to come ahead and show you this here. So here I've got a 3D graph, and I've got the three equations as shown before. So if I turn one of them on, there is a plane in 3D. Here is a second plane, and here is a third plane there. And we can see, all right, there's probably a point, somewhere around here where they're all intersect. And we want to find, well, what is that x, y, z coordinate for that there? So that's essentially what we're doing. So I'll come back to this one here. And so essentially to do this, we're basically just using, we're basically just going to turn it into like a bit of a matrix. It's not a matrix, but yeah, we'll go ahead and do that. So basically what we want to do is all we're really interested in is what are the coefficients of these x, y's, and z's, and we're just going to work with those numbers there. So, and this is known as like the row reduction method of to sort of eliminate a variable. So I'm going to rewrite out our three equations here in a matrix. So the coefficients for the first row are 1, 2, -3, and 9. So I'm just going to write it out as 1, 2, -3, and I'll just put a little spacer there and as our equals, and then we've got 9. Our second row is 2, -1, 1, 0. So 2, -1, 1, and 0. And for our third one, we've got -3, 4, -2, and 12. Okay. Alrighty. So essentially, we've got our three equations here, and so the way I'm going to set this one out here is I'm just going to write out on the left sort of what I want to do. So my goal here is essentially I want to turn these values here into zeros. So basically I want to do some manipulation where we're basically going to do it through sort of elimination to turn each of those values there into zeros. So let's go ahead. Where did we go? What happened there? So we're going to turn those values into zeros. So let's go ahead and do that there. So what I want to do first up is I'm going to redraw my first value out here. And I refer to this row as row 1, this is row 2, and this is row 3. So basically, firstly, if I want to make the 2 equal to 0, basically what I want to do is basically I want to take 2 of row 1 and subtract row 2 away from it. So I'm just going to say what I want to do here is I want to take 2 of row 1, take away row 2, and then put it back into row 2. So that's what I'm going to do here. So 2 times 1 is 2. 2 take 2 is 0. Now we go ahead and do it for all these values here. 2 times 2 is 4. 4 take -1 is 5. 2 times -3 is -6. -6 take 1 is -7. 2 times 9 is 18. 18 take 0 is 18. So there what we've done is we've eliminated we've made a 0 there. And now we want to make a 0 in here and change that -3 into a 0. So what I've got to do is I've got to take 3 of R1. I'm going to add row 3 to it. I'm going to put it back into row 3. So in doing that, 3 times 1 is 3. 3 plus -3 is 0. 2 3s are 6. 6 plus 4 is 10. -3 times 3 is -9. -9 take 2 is -11. And 9 3s are 27. 27 plus 12 is 39. Okay, so that's our first step there. We've created the 2 zeros there. Now we want to turn that 4 or this value here equal to a 10. So actually what I'm going to do is just eliminate that. So our first step is making these 1 zeros, and then our next step here is to make this one a 0 as well. So in that first step, we use row 1 to with R2 and R3. Now we've already used R1, so we can't use it again. So now in eliminating this 10 in the second row here, I can't use R1. I have to use R2 and R3 in eliminating it. So I'm going to rewrite out my row again here. So I'm going to do 1, 2, -3, and 9. I'm going to have 0, 5, -7, 18. And now what I want to do is I want to use a combination of R2 and R3 to eliminate the 10. And I can see, well, if I could double 5, I get the 10. So if I do R3 take 2 R2, that'll do it. So I'm going to do here R3 take 2 R2, and I'm going to put it into row 3. So the zeros, nothing's really going to change there. So 10 take 2 times 5, so 10 take 10, that's going to give me a 0. -11 take 2 lots of -7, so it's going to be -11 plus 14, which is going to be 3. And then I've got R3 plus, I'll take 2 lots of 18, so 36, that's going to be 3 as well. Okay, so what have we got here? Just keep in mind that each of these represents our X, Y, and Z values. So if I just have a look at my last line here, what I've got essentially is 0x plus 0y plus 3z is equal to 3. So really, I've got no x's, no y's. So really, I've just got 3z is equal to 3. So that means that z has to equal to 1. Okay. I can now sub that value into my second equation, into row 2. So if I have a look at row, so this is 3 here. Now if I have a look at R2, what have we got? We've got 0x plus 5y take 7z is equal to 18, but I know z is equal to 1. So then I can just say, well, 5y, so that's nothing. Take 7 is equal to 18. So that means 5y is equal to 25, or y is equal to 5. Okay. And now I can sub that y and z into my original equation, into row 1. So back into R1, we had 1x plus 2y take 3z is equal to 9. So that means 1x plus 2 lots of 5 take 3 lots of 1 is equal to 9. So that means 1x plus 10 take 3 is equal to 9. So that means x is going to be equal to 12 take 9 is equal, 12 take 10 is equal to 2. So we get that one there. So there's our 3 particular values. That's the coordinate where those 3 planes would intersect with one another. Okay. So this is the row reduction form of solving simultaneous equations. So I'm just going to write here. So firstly, not eliminate, but basically into zeros there, and then second this value. Yeah. Okay. Alrighty, so in this first scenario, there's always going to be a unique solution. In the next video I'm going to show you, we're going to look at what happens if there's no solutions or potentially infinite solutions, and we're going to go through those scenarios there. All right, thanks guys.